All right, so yesterday we talked about solving like multi-step linear equations. Linear just means you just have something like 3x plus 4 equals 8. You just have a variable like with an exponent of 1. Okay, so today we're going to talk about the different types of solutions that can come with linear equations. Okay, so linear equations in one variable, so meaning only one letter, can have one solution, no solution, or infinitely many solutions. Okay? All right, so we're going to talk about one type of solution at a time. Okay, so going down the page right here, we're going to talk about how you get one solution and what that even means. Okay? All right, so one solution means that only one value will make your equation true. Okay, and so what that means as far as like a graph, if I have two linear equations, it's just showing you where the two equations cross. Okay, so the linear equations will cross one time. Okay, so you may have a line that's like this, you may have a line that's like this. The solution will be right there. So where your lines cross. Okay, so if we look at this example down here, 4x plus 6 equals 18. We know how to solve that. We subtract 6 from both sides. So I get 4x equals 12, divide by 4, and x equals 3. Okay? And so all that means is, if I take 4x plus 6 and graph that line, and I take 18 and I graph that line, then it would show me that they would cross at an x value of 3. Okay? So this is saying there's only one number that makes this equation true. Okay? So 3 is the only number that makes that equation true. Okay? So the end result, so when you solve an equation, if it has, you know it has one solution if your end result has a variable on one side of the equation and a number on the other side. So if you're left with a variable and a number, you have one solution. Okay. All right. So now let's go back up and talk about infinitely many solutions. Okay. Infinitely many solutions means that any value will make this equation true. Okay, and so all it really means is that both sides of your equation are identical. Okay, so if you look down here, 5x plus 15 equals 5x plus 15. If both sides are identical, then you're going to have, we'll just say, for instance, this is 5x plus 15. And then the second line is also 5x plus 15. It's going to be on top of it. Meaning, no matter what number you plug in, you will always get the same value. Okay? So here, if I even went to solve it, if you just didn't recognize it was the same, and I have negative 5x, okay? Those x's go away. And I'm left with 15 equals 15. Does 15 equal 15? Okay, it does. That is a true statement. Okay, so that means there would be infinitely many solutions. Okay, so this blank here, blank for x will make the equation true. So any value for x. Okay, and so you can identify that type of solution If your variables cancel each other, so my variables cancel each other out on both sides, and then both sides of the equation are identical, or they are the same. Okay. All right, and then let's talk about your last type of solution, which is a no solution. Okay, so no solution just means there are no values that will make this equation true. Okay, and so one way I know that I will have no solutions is if I have two lines, so like 4x plus 8, if that was this line, and 4x plus 3 was this line, okay, those lines will never cross. Okay, if they never cross, then there is no solution. Okay, so let's look at what the equation would look like. So something like 4x plus 8 equals 4x plus 3. Okay, they're not identical like the previous. Okay, so it's not infinitely many. So if you start to solve this, I'm going to subtract 4x, subtract 4x. Those both cancel out. I'm left with 8 equals 3. Does 8 equal 3? Okay, it does not. And so this is a false statement here. Okay, so if your variables cancel out and you're left with like 8 equals 3, which is not true, then that means there are no values for x that will make this equation true. Okay, and so that just means that variables cancel each other out. So our 4x's cancel each other out, and both sides of the equation are different. Okay, so that's kind of how you can do a quick look to see what type of solution you will have. Okay, so let's take a look at some of the examples. So determining your type of solution. All right, if I have 3x minus 5 equals 7x plus 3, I can look at that and say, I'm going to have one solution. And the reason I know that is the variable terms, variable meaning whatever the letter's at, they are different values, okay? They are different. If they are different, then I will definitely have one solution. Okay? Then, moving on to the next one. Okay? If you first start off and just look, I have a 2 and a 2 and a 4x and a 4x. Everything about that is the same. Okay? So your variable terms are the same. I have 4x and 4x. And both sides are identical. Okay? So if my variables are the same and then everything about it is the same, I will have infinitely many solutions. Okay? And then no solution means if you look at it and see, okay, my variables are the same, I have 8x and 8x, but my other values are different. So both sides are different. The variables are the same, but both sides are different. That means that I will have no solution. Okay, so that's just by doing a quick look and not actually solving them on how you can tell what type of solution you will have. All right, so example 1 says simplify both sides of the equation. So I'm going to distribute here so that I can simplify both sides and see what I'm working with. Okay, so 2 times 4 is 8x. 2 times 5 is plus 10. Bring down my equal sign. 5 times 2x is 10x. 5 times 4 is 20. All right, so what I want you to look at first is the variable terms. Okay, those variable terms are 8x and 10x. If your variables are different, so I'm gonna go back up to here. So if my variable terms are different, we're looking at one solution. Okay. So over here we have variable terms are different. All right, and so I have just one solution that I will have. Okay, so it says the equation has blank, so it has different variables. This solution will mean that only one value will work and solve this equation. Okay, so I'm going to solve it here. I'm going to subtract 8x from both sides. Those go away. 10 equals 2x plus 20. Then I can subtract 20 from both sides. Get negative 10 equals 2x. Okay, and then I'm going to divide both sides by 2. And that would give me x equals negative 5. Okay, and so this would be my one solution. Okay, so this equation has one solution. The solution means that only negative 5, only x equals negative 5 will make both sides equal. Make both sides of the equation equal. Okay. All right, so let's look at another example. All right, so example 2. I'm going to simplify and combine some like terms so I can figure out what type of solution. So I'm not even going to solve this one out. All right, 2 times 5x is 10x. 2 times 4 is 8. Bring down the minus 11. Bring down your 4x. Distribute the 3. 3 times 2x is 6x. 3 times negative 1 is minus 3. Okay, so then I need to combine some like terms. So 10x, 8 minus 11 is negative 3. And then here I have more like terms. That'll be 10x minus 3. Okay, so I'm going to stop there. What you should notice automatically is that both sides of that are the exact same. I have 10x minus 3 and 10x minus 3. If everything is the exact same, I will have infinitely many solutions. So this one will not have just one solution. This means that any x value will work. Okay, and then let's look at example 3. All right, I'm going to bring my negative 4x down, distribute the 3, so plus 15x plus 18 equals, distribute the 7, 14x plus 7 minus 3x. All right, I want to combine like terms now. So over here, I have negative 4x plus 15x, that's 11x, plus 18. And then over here I have 14x minus 3x, that's also 11x, plus 7. Okay, I'm going to stop right here and look at things. All right, so what I notice is I have the same variable, but then my numbers are different. So same variable, but different numbers means there will be no solution. Okay? So there's no solution because I have the same variable, different constants. We'll call them constants. Okay. All right, so that's just a look at the type of solutions that you can have with linear equations.